Okay, so your vocabulary evaluation is that yours?
No, she said I could have a drink though.
Okay. Okay, so you were handed back your vocabulary evaluation. If you chose to keep it, fine, it's been recorded. If you chose to discard it, that's fine too. Okay? So it's a choice for you to make. Now, moving forward, as we know, this is on the schedule, and we've covered this up here. If you miss class, it's your responsibility to find out what you had missed. Sorry? That's been up there since the very first day. But some people maybe choose to read it, maybe they don't pay attention to it, or I don't know. That's for yourself to determine what we mean by that. But it means if you're gone, it's your responsibility to see what you have missed. So, with that, yes.
Number 3, I had A written, and you said the answer was A.
It probably looks like a Q.
Yeah, that was probably my fault. Sorry. Or is that meant to be?
No, it's definitely not supposed to be Q. Okay, but direct to protein synthesis in the cytoplasm is messenger RNA. So it is letter A. All right. Okay. On the left of this line, given no further instruction, what would you presume is happening here?
I know.
Well, just tell me. Well, that's happening, but the entire process. Okay. Sit down.
Do you need me to perform the Heimlich maneuver?
So we had said, what is everything, just the entire process with no further information, what would you think this is? There's 2 things that would give you a clue. Okay? Because of that and that. What is it when we say up on the bottom and on the top, what does that mean to you?
It's a double helix.
It's a double helix, it's double-stranded. What is the only nucleic acid that is double-stranded?
DNA.
It's DNA, okay? So then what can we presume, what is holding this DNA together? That's hydrogen bonds right there. So what is it that's moving this direction and breaking those hydrogen bonds? If you just want to say helicase, that is fine because there's only one form of helicase, and that is with DNA. Polymerase is a little different. Okay, so we've got these hydrogen bonds that holds this together. Okay. So if we were to illustrate this replication then, okay, what is it that would be complementary to adenine, but on the inside there? Thymine, okay? What is complementary to thymine? Now, as we're going over this, I'm just kind of surprised. Did we not remember this? Did we forget? Or did we not spend enough time on it? You've got to tell me.
I feel like we didn't spend enough time on like the names. I feel like I only knew them by like the GC.
And that's fine.
I didn't know about like the actual.
Well, then just say the letter. You don't have to say the name of it, adenine or
But on
thymine.
the test, like seeing
Okay.
Now that I see the questions again,
I understand it now.
Okay.
during the test, I don't think I fully understood the questions, which is my own fault. But
Okay. So what does G bond to then? Okay.
Something like C.
All right. So then C bonds to, we're a little bit off of our proportion here, but you get the idea. This C, and then C, okay? And then what are our last 6? You tell me. A, Okay. So then, whether you say adenine and thymine, where they say A and T, or cytosine and guanine, or C and G, who does not know what bonds with which nucleotide? Okay? It's important because each and every one of these is an individual nucleotide. Okay? So now, if it is DNA helicase, or just the helicase enzyme that breaks those hydrogen bonds in here, what is it that would seal this back together if we're doing DNA replication down here? Okay? What would we put down here if it's DNA now?
U. We know it's DNA. A, C, G,
Okay?
G.
And we'll just stop right here. Now, what do you notice about what we see here and what's in the box here? They're identical. Okay? So if you replicate something, in other words, we'll just say, does anyone even get powdered Kool-Aid anymore? Yeah. Okay? So this is your Kool-Aid. If you want to make your Kool-Aid at home, if you want to make your Kool-Aid, here's your
Sorry, I'm not on me. I'm not on me. What do you mean you're not on me? No, it's fine. Sorry. I'm sorry. Oh my gosh.
That is, again, your choice. So here's your Kool-Aid. Maybe you put, I'm going to say 3 scoops in there, and you really like the way that tastes. If you want to replicate that, you put 3 scoops in again, right?
Yep.
And that should taste the same, right? So the idea behind replicating something is repeating the process. So if this is replicating this, it's repeating the process so you have the same exact molecule. Okay? So CGG and then CGG here. Okay. Now, helicase has broken those hydrogen bonds. What is it that's going to form the hydrogen bonds? Now you got to be more specific. Now you have to say DNA. Because, and we know these are enzymes because they end in that, okay? Now, this is a different color. If we were just doing replication on both sides, this would have been black again. But what is your other polymerase? It's RNA polymerase. So, what does it mean right here? We're talking about something involved in RNA. So what are the 2 main, what I want to say, structures that we talked about with RNA? Nope, that's, okay, 2 forms of RNA. Messenger RNA is one form, and transfer RNA is the other. Okay, so if this is going to be, since it's in the nucleus now, in your estimation, is that messenger RNA or transfer RNA? Is that messenger or transfer? Is it messenger or transfer? It's messenger RNA. Okay? Because what does a scribe do? They read. Okay? So, if this is going to be a strand of messenger RNA, okay, what are our nucleotides out here?
It's C.
Okay, then I understand this is hard to see, but so cytosine, C, G, U. Okay, so then I'm going to put a box around these 2 3-letter segments. Okay? So here, well, we can come, because I have that up on the overhead again. But what process is this called when RNA polymerase reads the DNA? Transcription. Okay, who is confused about that, what transcription is? Okay, so if we write this term down, transcription, okay, we took the approach that even though that's a P, if it was a B, we'd call that a scribe. A scribe is someone who actually can read. So in this process, this substance here, messenger RNA, is reading the DNA, and that is a specific process. The author goes on to use the definition as process in which messenger RNA attaches to a template of DNA. That is the specific definition in the back of your book. So I don't know what you're writing as an example. At least I would be led to believe maybe it's shortened down and condensed, but that's mainly for your benefit. Okay? So this process where messenger RNA is reading the DNA, a scribe does that. That's why we call it transcription. Okay? Are we a little more clear on what transcription is? It's a process.
Yeah.
That you tell me, what does transcription mean? No. This is the enzyme that breaks this. The process is, okay. Okay.
Does transcription
What did we write down for a definition for transcription?
don't do it, Carson.
Carson, nobody is.
It doesn't say transcription.
Nobody is.
There isn't a trans. Oh wait, there is.
Process in which messenger RNA is synthesized from the template of DNA. When we say synthesized, we're talking about being read from the DNA. That's what that means. I just want to know, what did you write down for a definition?
Wait, for what?
What are we talking about?
Okay.
I think you. Okay.
I wrote the same thing.
Yeah, I wrote
Okay.
that.
So then, on your vocabulary evaluation in front of you, what does it say on that definition for what transcription is?
It doesn't have a transcription.
Yeah, it doesn't have transcription.
Oh, it wasn't on there? Okay.
That's probably why I
It
bring
has
that 20 out of 20.
semi-conservative replication.
Okay.
We got 20 out of 21.
Feel your name's down there.
Okay. So now I want to get to this here.
Why does Mr. Jones get to leave early? He's stealing his kids.
It's black.
He's kidnapping his
They
kids.
grow up nowhere. No water.
Okay, for some of you on your vocabulary evaluation, when you just had 3 letters, you had one side that said DNA. Then we said put your complementary pairs on there. Then it said RNA, messenger RNA underneath there, correct?
You're
Okay. So then should you had AUG, which is methionine, what does that say? Start. Then if you had UGA, U, G, and A, what does that tell the process to do?
stop.
Stop. Okay? That's all you had to do was write either start or stop for that. Okay? That's what we're looking for. Okay?
Are you okay?
Preston, what'd you write? I bet Preston tried to be as nervous. No, I wrote a little paragraph because I wanted to know what it was about. Exactly.
I will say, the only one I didn't understand was the last one, but it was
Did you get it right? No.
deeply
So I don't
mistaken.
think you did it right what it is.
Wrote what mRNA does.
So once we see UGA, according to what we saw here, what does that tell you on this table? UGA.
What starts?
What is
It means it stops. It means it stops.
So is it start or is it stop?
Stop it. It stops.
The process stops. Okay? So then, this is the code for assembling proteins here at the ribosomes because, yes,
What does you match up with in RNA?
adenine or A. Okay? So I was under the presumption that we understood that because you did an activity on that, right?
Yeah.
Correct.
Okay?
Actually, but I did it wrong,
For chance.
and he said I did it right. But I understand it now.
Okay? So now, this will leave the nucleus. That's why we have this here. Okay? Now, once it leaves the nucleus, what is going to happen at the ribosome?
Go to the huddle and it's going to tell the players
Okay.
their job.
Okay, in a matter of speaking, yes. Okay? So, which one of these two do we take? This one or this one? Why is it this one?
That's the RNA.
Because that's RNA. Why can this not be RNA?
It has a T. It's because it has a T. There's no messenger DNA.
There is no messenger DNA, that's true. And neither, it can't leave the nucleus. So the instructions are imprinted here on the DNA. This leaves the nucleus, okay? So then we have A, we've got U, we've got G, and then we'll just do CCG. Okay? Now, each one of these three-letter segments, this is messenger RNA. Each three-letter box is called a specific what? I don't know how to break this down any further. Whether we read it in the book, we talk about it up here, I don't know how to explain this any better. But some of you do have a good handle on this, right? So if you do, what worked for yourself? If you don't mind sharing. What worked for yourself if you don't mind sharing?
I studied and I put things together when it made sense to me.
Okay? And it's not going to make sense for everybody. Okay? I understand this. Or I should say, I understand that. Okay. So now, this is a specific, not just codon, but it's methionine, but it is a start codon. This tells the process to start way back here. So once this gets over here, what is a second form of RNA we talked about? Anticodons, which is what though? Transfer RNA. So what that means then is what is going to bond to this molecule, but it's transfer RNA now. Okay, so we have U, A, and C. And now, these are not codons, those are what? And it would specify MET, or methionine. What are our next three letters?
Do you go from left to right or right to left?
And just go right to left. Yep. And then I don't know specifically which amino acid. Yes. Here? Okay. So then this is a different amino acid.
That face looks like now. The guy. Did he have surgery?
Oh yeah, I wonder what his face does look like.
Okay, so then our next three letters were G, G, and C. Okay, so here's G. What do we say? G, so here's where they consolidate, and then C. So our next amino acid now is glycine. So what we would do is put GLY there,
Oh yeah, that's.
because that is an amino acid. So
How do you? I don't know if you guys went over this today. I wasn't here. How do you know the abbreviation of all?
well,
It's mainly just.
you can just do this.
My guy.
It's basically just the first three letters.
It is, yes.
So it's just the first three letters.
It doesn't really matter, Tom. That's not what we learned.
Yeah, Tom.
Yeah, maybe if you were here, you'd know.
Yeah, maybe if you were to watch a science channel.
Okay. So then, what are our next three letters on messenger RNA? U, U, and A. So U, U, and A. Okay? So then, what are our corresponding letters here then?
A, and probably the T. Oh, I'm sorry, my bad. That's my bad.
Now,
Why are those ones so much longer?
okay?
That's all.
So the code for this amino acid was AUU. Did we do that right? You didn't read this one last time, did you? You read this, correct? Okay. So CCG. Because I think you read the wrong one. CCG. So CCG is, because that's what these are, is codons. Okay? These are coding for,
Cody.
that's codons in messenger RNA. So CCG, so C, C, and then G, okay, should have been proline, okay? Not glycine. Okay. Therefore,
We just leave that up there, huh?
Her chant.
We just leave it on.
Wait, but it's there should be C.
Time's passing.
PRO are proline. Okay?
You do read it left to right.
Some days you're the dog, other days you're the
So then we've got UUA. Okay. So U, U, and A, we've got leucine then. Okay.
If you come over and you pay me
Some of you may perhaps think, we're doing this again tomorrow. Well, then that means you understand it. Okay? If you're sitting out there, because I'm just getting the impression that we don't know what we're doing. Is that a correct presumption? Okay? So I don't know what do we need to do on this end to try to close that gap. Okay? Think about that between now and tomorrow. We'll review again tomorrow and then have the exam on Wednesday. Okay? So there again, I think some people are absent for, is it oral interp again tomorrow? Okay. So it's all part of responsibility. So if you are having problems with this, if you know how to read this, this will help you out a lot. You don't have to, we're not going to do a whole strand of replication where you have to do 15 of these. No, probably just 3, and that's what we did. Okay? So what is the difference between replication and transcription?
Transcription is reading
Transcription is reading. Specifically what though?
the codes.
The DNA. Where though?
The 3 letter codes.
In the nucleus. Okay? Then that message gets sent from the nucleus, and where's it going? To the ribosome. And those codes or codons in messenger RNA, the transfer RNA picks up these amino acids. Okay? All right. Any questions? All right. We will pick up with this tomorrow or next time.